In this example, we have a wheel and sliding bars. The wheel is not fixed at a certain point, so the wheel is free to move back and forth, while the sliding bars also move back and forth. The bars, one of them has a linear velocity of 0.8 meters per second, the other one is in the opposite direction with 0.6 meters per second. As a result of that, there is a contact between the wheel and the bars. The first bar on top is in contact with the wheel at a surface with a radius of 100 millimeters from the O point, the midpoint. And then the other one is in contact with the surface from the midpoint of this wheel by 160 millimeters. Therefore, the velocities that are going to be measured on the wheel at this instant will be, for this one, will be equal to VA in this direction, and for the other one, the velocity that's going to be measured at this point of the wheel will be the VB velocity. Now, we have found out two velocities that belong to a single rigid body, and the single rigid body we assume that it's translating and also rotating. Now we can write out a bunch of equations for this, and we can declare a frame to investigate this motion. For example, we can say that this is the x-axis, and in the vertical direction, that's our y-axis. And we can write out an equation, for example, for VA velocity. VA velocity of that wheel would be equal to, for example, I can write the equation for VB. Why not? VB plus omega, which is the angular velocity vector of this wheel, cross product with R A with respect to B. I can write out an equation in this way, and from this equation I can directly solve for omega, by the way, because I know the distance between these two. I can write out this RAB vector. RAB vector would be, in this case, 100 plus 160, 260 millimeters. Let me write it out in meters, 0.26. 0.26. Let's decide on the direction. It will be in the y direction, and this is the location of A with respect to B. So from B to A, that is a positive J direction. So from here, I can directly solve for omega, actually. However, you'll see in the solution, we have done it in a different way, and we can write also equations for V0, because the question asks us about the velocity of point P, so we might as well first calculate the velocity of V0, then find omega, and then write an equation for Vp depending on O. But we don't have to do that, actually. Anyways, so V0, the other type of equations are already written, so I'm not going to repeat those. So let me just cancel this V0. We can write out a Vp equation as a matter of fact, and then this would be equal to V0. Nope, not V0. We did not calculate V0. We know VA, we know VB, and from this equation, we can actually calculate omega. By the way, this omega is going to be omega k again. Omega k. So you need to make your cross product based on these unit vectors. K cross product j. The resultant will be a -5. Therefore, this VP could be this equation could be written out for VA, for example. I could have written it for VB as well. So I can say VP is actually equal to VA plus omega, the angular velocity of this wheel, cross product the distance vector from A to P, or P relative to A. And P relative to A is actually something I can write out. This is in the x direction 160 degrees. By the way, we are writing this distance vector from A to P. From A to P, we go in x direction and in the negative y direction. So it will be 0.16 I minus 0.1 J. Okay. Omega is already determined in the previous step. VA is known. Now I just calculated this distance vector so we can find out the velocity of P. This quick, easy way to calculate the VP. The other way is already in the equation set written down. First of all, we are trying to calculate the velocity of this wheel. If this is asked, obviously you need to do that, but the only thing asked is about the velocity of point P. But as an extra information, you might as well want to find out this V0. The most convenient way to find out that information is write an equation for V0 using VA, write another equation for V0 using VB. You will have two unknowns. One of them is V0 speed, the other unknown is omega, and you will have two equations to work. Therefore, you will solve V0 and omega from these two equations. And then you can write out a third equation for Vp, making use of V0 and omega, which are already found in the previous step, and then that's your result. Or you could have done what I just write out here. You could have used only VA and VB, and then find out omega from the omega information, write the equation for Vp, use VA or VB, depending on your choice, and you will be able to calculate the Vp as a result of the previous steps solution for omega.